Hello everyone. Today we are going to discuss the very conclusive topic related to the electric potential. Here today we are going to discuss that system of charge of dipole. Earlier we have discussed in two sessions that the dipole have negative charge and dipole have positive charge. In these cases we have discussed that the electric potential at axial point, P, what it will come? It came V is equal to 1 upon 4 pi epsilon naught P upon R square. So at that point you can say that that one is the axial in first session, in first video of this system of charges के case. Now second video we have discussed a point which is here, a point P which is equatorial point, you can say that. In that case the distance from this point, the distance from this negative charge having the angle theta. So here the potential came in equatorial case, equatorial is 0. So in two cases we have discussed. In axial there is this one amount of potential come, and at this point here or here anywhere you can take it this point which is the equatorial one. So in these two cases the first potential come is some have the formula V is equal to 1 upon 4 pi epsilon naught P upon R square. But whenever the point is at the equatorial point, yani equal distance from the each of charges, then the potential, the resultant potential is 0. In this case we can say that the work done over this point is 0. How it is? The Q into delta V. So there is no potential difference. Delta V is 0 here. So the work done over this point is 0. So equatorial के case में there is no work done over this surface. Today we are going to discuss a different type of topic which is related to the dipole, and also we want to calculate the electric potential. But in today's topic, these two topics also the conclusive one and the new formula will came and which will satisfied in these two cases also. What is that? See this one. From this point you can say the center of dipole, we will take an arbitrary point. P, as we have taken in axial also, as we have taken in equatorial also. So today we are taking a point which having the distance r. Similar one, this one also we have taken the r distance in earlier video, and we have also taken the r distance from this one. So this is our first application, this is our second application, and today we are doing our third application. So in that case we can easily understand that today the point which having the distance r making the angle with sin theta with the center of dipole. So today we are going to calculate V here. Okay, so be concentrative. We will calculate the point P here. So initially we got the value of axial case. So here we know that the dipole moment will be negative to positive. Our dipole moment will always negative to positive. So we can resolve this dipole moment into two components. Before resolving, we will try to understand that the P point is an arbitrary point having the angle theta with center and the making the distance r. So the P की जो particular position is, you can say that r theta is this one. Now resolve. Let resolve dipole moment P vector into their components. What are their components? Let's see that. First component of this dipole moment with along this point will come P cos theta, which is along from this point to this point. So that is the center, you can say that O is there. So O से लेकर P. So that is along OP. Now second, P sin theta, which is perpendicular to OP. So see here, see this have the component, or you can say that the component, you can say that here the P cos theta, and that at that point there is a perpendicular, you can say that is point per either this side or this side, that will be a perpendicular, which is, you can say that P sin theta. Okay, so we are calculating here the dipole, or you can say that we are considering the this point only, the P cos theta, you can say that, because this P cos theta is along OP and we are trying to calculate here, we are trying to calculate potential here. So our main consideration is what? O से P का distance. So we have resolved these components into two components. The dipole moment is resolved into two components. Then what we will see at P point, what will be the electric potential at point P. At point P. The P point is axial point for P cos theta. You can see that P cos theta is also going along OP, and the P point is along line this one where we want to calculate the electric potential. So both points are the axial one. Both points are the axial one, and we know the value of axial potential formula. So with the help of this one, we can write it V1 upon 4 pi epsilon naught. Here the component is what? P cos theta. So P will become cos theta, and the distance will remain as it is, R square. So along this point, our you can say that horizontal component, this one, horizontal component have the electric potential is 1 upon 4 pi epsilon naught P cos theta upon R square. Now the second component is also there. You will see that at another component is P sin theta, electric potential will be 0. Why it is 0? Let me explain it. It will be 0. देखिए, let's see that we have taken that initially we have taken the dipole के along the equatorial point, the equatorial point having the potential 0. Here also what is happening there, our reference or our arbitrary point is along this one, making the angle theta. So from that point we have an equatorial, this one. So whatever will we come to this equatorial point, it will be V equatorial is equal to 0. So that component at another component P sin theta, electric potential will be 0 because with respect to OP, the P sin theta is at equatorial point. So in that case our potential will be 0. So that is the reason why the electric potential at the equatorial point with reference to this one O and P having the angle theta with dipole have the 0 one. Now total electric potential क्या हो जाएगा? Potential it will be you can say that both components, horizontal components as well as the vertical components, So horizontal components we have, or you can say that here the vertical components is 0. The horizontal components have 1 upon 4 pi epsilon naught p cos theta divided by r square, and the vertical component is 0. So our resultant will be equal to our horizontal component p cos theta divided by r. That is very interesting and important relation comes in form of this formula. Now, we are using the both relations, this one and equatorial one, and we concluded with the V. So we finally got the 4 pi epsilon naught p cos theta divided by r square. So this formula will satisfy definitely this one also and this one also. If we will see that the point P with respect to the dipole making the angle theta is 0. So in axial case, V axial, the theta is 0 here, theta is 0 here. So 1 upon 4 pi epsilon naught P cos, we will put the value 0 here and r square. So V axial 1 upon 4 pi epsilon naught, the cos 0 is 1, so P r square. So that is what we are having. The axial dipole moment is same with the help of this formula, and same will happen with equatorial also. In the case of equatorial, theta is 90 degree. So whenever the point is equatorial, then theta will be 90 degree. We will put the 90 in this formula and we will calculate the equatorial electric potential 1 upon 4 pi epsilon naught P cos 90 degree divided by r square. So finally we will receive that the value at equatorial point is 0 because cos 90 is 0. So in that case we are able to help out or configure out that this formula, or you can say that the formula is coming an arbitrary point P having the angle theta and distance r will gives the a conclusive formula which satisfied axial condition and the equatorial condition, or any point with respect to dipole, either here the angle making of theta or this side angle making of theta, whatever point you will take with respect to the dipole system, our equipotential or our you can say that electric potential will came in this with the help of this formula only. So this is the basically conclusive nature of all the applications related to system of a dipole. So that is what we have done in this application. If you have any query, please comment me, or you can contact me directly to resolve out all these problems. We will see in later in next problem. Okay, thank you very much.